Hello everyone. In this video, we are going to discuss about the implementation of timers using Delta SS2 PLC. Okay, right. So if you see that types of timers, there are mainly three types of timers are there. So which are on delay timer, off delay timer, accumulative or retentive timer. Right. What is on delay timer? What is off delay timer? And what is accumulator timer? See. So on delay timer is nothing but this timer will provide the delay in during the on period, right? Suppose if you take one example here, so let us you take this circuit, okay? A voltage source connected to a bulb with one switch, right? So now whenever this switch is closed, instantly this bulb will glow as per this circuit, okay? So but suppose if your requirement is whenever your switch is closed, you want some delay, so then in such a case you have to use the on delay time. So that means during on period of a particular device, so there must be some amount of delay. So in such a case you have to use the on delay timer, right? So when you use this on delay timer, there is no delay in off. Okay, that means whenever you switch off this switch, instantly this bulb will off. Okay, so when you use the on delay timer, so there will be delay in only during on period, right? When it is off, so there is no delay. Okay, so this is about on delay timer. So then what is off delay timer, right? So as the name itself says that there is a delay during off period, right? That means if the switch is off here, so that means whenever you open the switch, instantly this bulb will not off. So there will be some delay. So when you use these off delay timers, okay. So but during on period, the bulb will glow instantly. Okay, is it understood? In on delay timer, so whenever you close this switch, the bulb suddenly will not glow. There will be some delay. Okay, so now whenever you open the switch, then it will suddenly off. So when you use off delay timer, so whenever you close the switch, the bulb will instantly glow, right? During off delay timer, when you use off delay timer, whenever you switch is closed, the bulb will go instantly. But whenever you open this switch, there will be some delay in switching of this device. Okay, this is about the on delay timer and off delay timer. Okay, so then what about the accumulative or retentive timer? Right, accumulative or retentive timer is a special purpose timer. So generally this timer will store or retain the previous data even though your PLC is switched off. Okay, suppose if your experiment is running, right now suddenly the power supply to the PLC is gone. So then in such a case, so when you use on delay timer or off delay timers, there are some timers, right? If you use such type of timers, then they will not retain the timer value which is there before this power cut. Okay, so once the power came, so then now the on delay timer and off delay timers, those timers will start from again 0. Okay, so but whenever you use the accumulative or retentive timer, so when the power supply is gone, so that timer will store the previous data, previous value of data, and whenever power supply is came, it will start counting the time from that time itself. Okay, so that type of timers are called the accumulative or retentive timers. So for example, suppose if you take one example, so here you are having one motor, right, or you can say this as a pump. Okay, so you are filling the water into this this container through one pipe. Okay, so now so the time taken by this bottle to completely fill is, let us assume 10 seconds. Okay, 10 seconds is the time to completely fill this bottle. Now, whenever you switch on the motor through PLC, right? So the motor will start pumping the water, and the water will be filled into the container. Okay, so now after 5 seconds, suddenly the power to the PLC is gone. Okay, that means power supply is gone to the PLC. Then the motor will also off. So the water will not fall into the container. So as it is switched off at 5 seconds, so the container will be filled up to half. Okay, so now again, if the power supply came, now the timer has to count the time from 5 seconds onwards, not from 0 again. Okay, so from if you count from 0 again, the motor will run for 10 seconds. So the container will overflow. Okay, it should not happen here. Okay, so whenever power supply to PLC is came, the PLC has to count, or the timer has to count. Okay, PLC timer has to count the time from 5 seconds onwards, not from 0, right? That type of timers are called the accumulative timers. Okay, those accumulative timers or retentive timers will store the previous time, okay, before the PLC has switched off. Okay, this is a special purpose timer. So these are the 3 types of timer. Now let us implement the first timer, which is on delay timer, using the Delta PLC. Okay, so for that purpose we are going to take one example. The example is a 24 volts DC motor on off control with 2 momentary push buttons. Here in this example we are going to take one DC motor, which is a 24 volts motor, and this on and off of this motor is controlled by 2 momentary push buttons. So there are 2 types of push buttons are there: momentary push buttons and maintain push buttons. Okay, so in momentary push buttons, in the sense, so when you press the momentary push button, it will on, and if you release your finger, it will off again. Okay, so that is called the momentary push button. So maintain push button is another thing. So whenever you press one time, it will on, and it will be there in the on mode continuously, right, until you press the second time. Okay, that is the maintain push button. So here in this example we are going to use the momentary push buttons. Okay, momentary push buttons in the sense, so when you press the switch or button with your finger, it will make the contact, and if you release the finger, it will again come back to off. So that is the momentary push button. Okay, so here we are going to use 2 momentary push buttons. So one push button is used for switching on the motor, and another push button is used for the switching off of the motor. Okay, right. So now with this example we are going to implement the on delay timer. Okay, so on delay timer in the sense, there is a delay during the switching on period. Okay, so whenever you press the on button, your motor should not start instantly. There will be some delay, right? So in such a case, you have to use the on delay timer. Okay, that on delay timer we are going to implement with the Delta PLC, which is a SS2 model. Right, how to write the program for on delay timer? Let us see here. So open the WPL soft, which is there on the desktop. Here you take the new file. Okay, your program title is your wish. So here I am writing this as a on delay. program title, I'm setting it as a timer, and file name as on delay. Okay, so here you have to select the model type as PLC and the model number as SS2. So click on OK. So here you have to write the ladder diagram program. So click. Right. So in this example, whenever you press the on button, on push button, it will make the contact and the 24-volt supply will be given to X0 here, right? So X0 will be energized whenever you press the on button. If you release it, then X0 will be de-energized. Okay, as it is a momentary push button, whenever you press the button with your finger, it will make the contact and X0 will be energized. And if you release your finger, it will go back and X0 will de-energize. The same thing will be applicable for this off button also. Okay, off button also is a momentary push button only. Whenever you press it, X1 will be energized, and if you release your finger, X1 will be de-energized. Okay, we remember these points, right? So now I'm going to press the on button and X0 will be energized, right? So whenever X0 is energized, so then Y0 should not on instantly for on delay timer. Okay, so whenever I press the on button, the timer has to start first, and I will set the time as 10 seconds. After 10 seconds, the motor has to run, right? So my motor, I don't want to run instantly when I press the on button. Okay, after pressing the on button, my motor has to switch on after 10 seconds. Okay, in such a case, you have to use the on delay timer. So during off period, when I press the off button, the motor has to instantly switch it off. Okay, right. So as on button is connected to X0, so whenever I press the on button, X0 will be energized, right? Whenever X0 is energized, timer has to on here. Okay, so the timer is there in application instructions. You click on the application instructions, which is F6, and here API name, you simply type TMR. Okay, so TMR is a timer. Here, if you want to know the description about the timer, you go to the help. Under help, you will have the timer description. So it is a 16-bit timer, and this timer is having two variables, S1 and S2, and S1 is the timer number and S2 is the set value. Okay, so timer numbers here in this in this software you are having number of timers, so which starts from 0 to some 256, I think. Okay, so T0, T1, T2, T3, T4, like that. Okay, you go to the device range here. I will show you. SS2 series I'm going to. Right here, T is the timer. Okay, here you are having 100 milliseconds timer, 10 milliseconds timer, 1 milliseconds timer. Okay, so these 100 milliseconds timers are from T0 to T126, as well as T128 to T183. So 127 T127 is not there here. Okay, when you use T0, when you use T0's timer number as T0, so then that timer is a 100 milliseconds timer. Okay, suppose if you use timer number as T200, so then that timer is a 10 milliseconds timer. Okay, so that means it will start counting its value for every 10 milliseconds. Okay, and if you use T127, if you use, it is a 1 millisecond timer. Okay, right. So like this, you will be having T0 to T55, T255. There are total 256 timer numbers are there. So you can use any number here. This one is the timer number. So that timer number may be from T0 to T256. Okay. So from T0 to T250, not 656, it is T55. Okay. Between T0 to T55, there are number of timers. Some timers are 100 milliseconds timers. There are 10 milliseconds timer. There are 1 milliseconds timer also. Okay, so there are some timers which are accumulative timers also. Okay, if you see here, from T250 to T255, this is a accumulative timer. Okay, and also it is a 100 milliseconds timer. And T240 to 245, it is a accumulative timer with the 10 milliseconds. Okay, and T246 to T49 are accumulative timers with 1 millisecond, like that. So we will use one timer in our application so that you can understand. Okay, TS1 is the timer number. S2 is the set value here, right? Whenever you use the timer, and you will set some value here. Okay, so that value is the count value. Suppose if you are taking 100 milliseconds timer, which is T0. So here I am taking T0. So here from 0 to 255 you can take. I am taking the T0 timer, and I am setting the value to 100 here. 100 here is the nothing but 100 counts here. For every count it will take 100 milliseconds. Okay, like that there will be 100 counts. 100 counts into 100 milliseconds is the total time. Okay, so 100 into 100, 10,000 milliseconds. 10,000 milliseconds in the sense 10 seconds. Okay, like that you have to calculate the time. Okay, suppose I will use the timer number as T200. Okay, instead of T0 I will use here T200. Okay, now this T200, it is a 100 milliseconds timer. Okay, one step is nothing but here, sorry, not 100, 10 milliseconds. Okay, one step is nothing but 10 milliseconds. So there are total 100 steps. Set value here is 100, so there is total 100. So this 100 into this 10, total 1000 milliseconds will be there. So total time will be 1 second. Okay, like that you have to calculate the time. Right, I'm taking first timer as a T0. So T0 is a 100 milliseconds timer. So when I kept here K value 100, then the total time will be 10 seconds. Okay, so whenever I press the X0 here, whenever I press the on button, on push button, X0 will be energized. So whenever X0 is energized, timer will start running. Okay, and it will start counting the value for every 100 milliseconds. Then whenever it reaches the 10 seconds, T0 internal contactor T0 will be energized, and whenever T0 is energized, our output Y0 has to energize, right? So when Y0 is energized, this DC motor will get the supply so that it will run. Okay, see, run here. Now when I press the on button, X0 will be energized. That means X0 will be on. Whenever X0 is on, you see here your timer will start counting, right? K53 like this up to K100 it will count. Whenever this value reaches to 100, it will be energized. T0 will be energized. So whenever T0 is energized, Y0 will get the supply and Y0 will be energized. So whenever Y0 coil is energized, here the output of the motor will get the supply and motor will run. Okay, why not is energized in the sense the motor will be running. Okay, so as I said before, this X0 is a push button, momentary push button. Okay, so now when you will press the button and you will immediately you will release the finger also, so instantly it will go off, right? See here, whenever you press it, it will make the contact and X0 will be energized, and if you release your finger, it will be off, so X0 will be de-energized. So you will run again like that. So first, if you on this, timer will start counting. So instantly, if you remove your finger, that means X0 will be de-energized. So your timer will go into off. Okay, it will not going to continuously run the time. So because of that reason, you have to provide some latching here. Or you can also use when you can use latching, or you can use some auxiliary contactors here. You insert one row. Whenever you press X0, let us assume that a coil, momentary auxiliary coil M0 will be energized. Okay, right. Whenever you, even though if you release your finger on X0, so the M0 should not go off. That means here you are going to use latching with address Y0. So in parallel to X0, you are going to use another contactor with address M0. Sorry, this is M0. So this is called the latching of the circuit. Okay, so this is the power supply rail. So when X0 is on, Y0 will M0 will on, right? Whenever M0 is on, this conductor is also on. So that means even though if this is off, the supply will go through this contactor to M0. So continuously M0 will be in on mode only. So now here I will keep M0. When M0 is on, your timer will start counting, and whenever it reaches to your time set value, then T0 will be energized. When T0 is energized, and Y0 will get the supply so that the motor will run. You see here, make it run. I'm pressing on button and releasing the button, right? Even though if you press and release the button, M0 will be in on mode only. Right now M0 is on, your timer will start counting, and whenever this K value reaches to preset value, T0 will be energized. When T0 is energized, Y0 will be energized. Y0 is energized in the sense your motor will run. Okay, so now you have to off the motor. So how you can off the motor? By pressing the off button. So this is also momentary push button. You will press it and release it. Okay, whenever you press it, X1 will be energized. Right, whenever X1 is energized, your Y0 has to off. Okay, so that means you have to keep one contactor with the X1 either here or here. Here you keep X1 with a normally closed here, right? So normally closed contactor in the sense initially it will be in closed mode. Whenever it is on, it will become off. Okay, so see here, whenever you press the button, X1 will be energized, right? As it is a normally closed button, initially it will be in on mode, right? Whenever X1 is energized, it will become off. But whenever it is off, the power supply to M0 will be disconnected. right? Then M0 will be de-energized, and M0 is a de-energized. This will be, the timer will not get the supply and timer will reset to 0, right? So whenever timer is reset to 0, this T0 will be de-energized and Y0 will go off. Okay, see. Right, you observe here X1, which is normally closed contact. Okay, as it is a normally closed contact, it will be initially in on mode. Okay, so now I am going to press the button, on button. So whenever I press the on button, X0 will be energized. So that means X0 will be set on. And when I release the button, it will off. Even if it is off, the power supply to M0 will be maintained by this latching circuit. So whenever M0 is on, timer will be running, and this timer value reaches to preset value 100. So then T0 will be energized, and T0 will be energized, and Y0 will energize, and the motor will run. Okay, so now I have to switch off the motor. Okay, so to switch off the motor, I will press this button and X1 will be energized. Right, X1 will be energized in the sense this will be on. Okay, whenever this is on, initially it is normally closed, so it will become open. So when it is open, this supply will be disconnected to this M0. So M0 will be off here, right? So M0 is off. This timer also will come back to 0. It will not retain the previous value. And when T0 will be de-energized. So when T0 is de-energized, Y0 will be off. The motor will off. So now, even though if you release the finger, on this off button, so that means when you release the finger on off button, this will be, X1 will be de-energized. That means X1 will be set to off. Even though if it is off, Y0 will not be on. Okay, this is how you can implement the on delay timer. Okay, so there is a delay in on of the motor only. So there is no delay in off. Okay, right. Now with the same example, let us implement the off delay timer. Okay. Same example I am considering, and I have to implement the off delay timer. So off delay timer in the sense, there is a delay when I press the off button. Okay, when I press the off button, the motor should not off instantly, right? After 10 seconds or 15 seconds, the motor has to off. And during on period, there is no delay. Okay, whenever I press the on button, the motor has to instantly on. Okay, and it will be continuously running. Now whenever I press the off button, the motor should not off instantly. There should be some delay. This is implementation of off delay timer. So for this, write the program. So you delete this program. Now write the program. So first one is, first you press the on button. Whenever I press the on button, instantly Y0 has to on, right? Whenever I press the on button, that means X0 is energized. Instantly Y0 will be energized. Okay, when X0 is on, Y0 is on. Right, as this is a momentary push button, you have to provide latching circuit with address Y0. Okay, now even though if you release the finger on your on button, your continuity of supply to your Y0 will be maintained through this contactor. Right, so now the motor will be in continuously on mode. So now I am going to press the off button. Off button is X1. Okay, I am going to press the off button. Whenever I press the off button, X1 will be energized. Whenever X1 is energized, instantly the motor should not off. The timer has to start. So you take the timer from applications, TMR, and timer number will be anything from T1 to T255. So here I'm taking T1, and where T1 is also a 100 milliseconds timer. So if you keep 100 here, 100 into 100, 10,000 milliseconds. So 10 seconds is the delay I am giving. So let us see, I will be keeping 150 now. 150 is 15 seconds. After 15 seconds, the motor has to off. Okay, whenever I press the off button, X1 will be energized. When it is energized, the timer will start counting, and the counting value reaches 150. T1 will be energized. When T1 will be energized, this motor has to de-energize. That means the supply to this should be disconnected. For that purpose, here you have to connect a contactor with the address T1, okay, which is normally closed. Now whenever T1 is energized, that means set our counting value reaches to 150, then T1 will be energized. So whenever T1 is energized, so this normally closed will become open. So that means whenever this is open, the supply to this will be disconnected and it will become off. Okay, see, let us observe this. So now press the on button and release it. So even though if you release the on button, your motor will be continuously running. Okay, so now I am pressing the off button. Whenever I press the off button, what happens? Timer will start running. Okay, so whenever this set value reaches to 150, so T1 will be energized. When T1 is energized, this, as it is normally open, it will open. Normally closed, it will open and it will be disconnected. Okay, why not will off? That means motor will off. So this is the off delay timer. But here, if you clearly observe, there is some mistake. So what is the mistake? Here this X1 is continuously in on mode only. So that means continuously it is energized. So but as we are using a push button here, you will press it and release it. So that means you will press it, X1 is energized, and if you release it, X1 is de-energized, right? So that means it will become off. See here, on, continuously it is running. It is off button, press it. Whenever you press it, and if your finger is not removed, timer will be in on mode only and it will be counting, right? Whenever you release the finger on this timer will set to 0. Okay, so why not will not become off. So what you have to do here you have to provide the latching again, right? So latching, for providing latching here, when you provide the latching here, the T1, it will not work out. Okay, why? Because T1 will be energized until T1 will not be energized until it will reaches to 150. Okay, the count value when if it is less than 150, T1 will not be energized. So you cannot provide latching for this circuit with the T1. So for that purpose, here I have to use one auxiliary contactor coil M0. Okay, so whenever I press the off button X1, auxiliary coil M0 has to on first. Okay, so this auxiliary coil M0 has nothing to do with, okay, it is not connected to anywhere in the hardware. Okay, it is simply a dummy coil. Let us think that it is a dummy coil, but it is helpful in program but not in hardware. Now I am keeping latching here with the M0. Okay, whenever you press the off button, M0 will be on. Okay, if you release it, as there is a latching here, this M0 will be in continuously on mode only. Now when M0 is continuously on mode, now if you keep M0 address here, when M0 is continuously on, the timer will get the supply continuously, so it will be counting time continuously till it reaches to 150. Whenever it reaches to 150, T1 will be energized, so that T1 has to off this Y0. So here you have to keep T1 with a normal close. Along with that, here also you have to kept the T1. If you do not kept T1 here, your program will not work. Okay, M0 will be continuously in on mode. If it is not there, so then timer will be in continuously at T150 only. I will show that also without this. Let us see without this. So now whenever I press it and release it, motor is running. When I press the off button and release it, M0 will be continuously in on mode. So M0 timer will get supply. Timer will continuously run. So whenever this timer value K value reaches to 150, so then T1 will be energized. So that T1 will make this off. As it is normally closed, it will become off. So whenever it is off, it will be off. Okay. So but if you observe here, this timer count value is 150. It will not set back to 0. Okay, so if it is not set back to 0, so now if you switch on this, your motor will not run. This is the on button now, right? Even though you press the on button, your motor will not run. Why? Because T1 count value is 150, which is equal to the set value. So T1 will be in continuously on mode. So when T1 is continuously energized, so this will be open here continuously. So because of that reason, Y0 will not get the supply. So even though if you press the on button, your output Y0 will not be energized. Okay. So what you have to do here, so whenever this Y0 is off, this T1 has to set the count to 0 here. So when it will get it will count set it to 0, this M0 is off. How can you can make this M0 off? So by disconnecting the power supply to this M0 coil, right? How you can make it? You can make it by taking one contactor here with address T1. Okay, so with address T1. So this whenever this T1 is energized, this Y0 also should off. At the same time, this coil also should off. So this is actual program. Okay. Now you run it. First press the on button. Output will be energized. Even though if you release the button, output will be continuously energized. Now if you press the off button, your timer has to start running. So even though if you release it, the timer should not disturb. It will continuously count up to the 150. Whenever it reaches the 150, T1 will be energized and it will become motor off as well as M0 off. So M0 is off, so this timer will reset it to 0. Now if you switch on again, the motor will on and continuously on mode. When you press the off button, timer will start counting. After 15 seconds, it will be off. Now the program is correct. Okay, so this is how you can implement the off delay timer. Okay, and the next timer is retentive timer or accumulative timer. Okay, so during on delay or off delay, so these timers during on delay or off delay, So whenever supply to this is disconnected, it will set to 0 in case of on delay timers or off delay timers. So but in case of accumulated timers, it has to retain its value even though power supply to that is off. See how it happens. So for that purpose, I explained already this example now. Filling the water bottle with one motor. Okay, whenever I press the on button, this motor has to on and it will pump the water to the bottle. Whenever the bottle is filled, it has to off automatically. So let us assume that this bottle is taking 10 seconds. Okay, this bottle is taking 10 seconds to fill. So after 10 seconds, the motor has to off automatically. Okay. For that program I am writing. So whenever I press the X0 button, my motor will on. Okay, motor Y0 will on. And along with that, the timer also should on. Okay. See here, whenever the motor is on, it will start filling the water to the bottle. Okay. So you have to count the time, which is 10 seconds whenever you switch on the motor. So whenever Y0 is on, with that Y0 address, you have to on the timer also. Okay, so timer TMR, that is here. So the timer here, what you have to use here is the accumulative timer. So what is the accumulative timer number? Go to that timers. So accumulative timers here are, see this row from T250 to T55 are the accumulative timers, right? When you use T250, it is the accumulative type with 10 milliseconds. Okay, here also you are having T40 to T245. So these are the accumulative timers with 10 milliseconds. T46 to 49, it is 1 millisecond accumulative timers. Okay, I am using 100 milliseconds accumulative timer, which is T250. Okay, here I am using timer value is 250. So 250 timer is a accumulative timer with 100 milliseconds for each count. So on counter value I am taking it as 100, right? So 100 milliseconds timer with 100 counts, it will give 10 seconds. Okay. Another thing you have to do here is X0 is a push button, momentary push button. So you have to provide the latching here with address Y0, so that even though if you release the on button, it will be continuously running the motor. Okay. Right, whenever I press the on button, what happened? Right, whenever I press the on button, Y0 will be energized, and release it, it will be continuously in on mode only. Okay. So whenever Y0 is energized, it will, the timer is also on and it will start counting its value. Okay, whenever it reaches to 100, then your motor has to off. Okay, 100 in the sense here 10 seconds. After 10 seconds the motor has to off. So 10 seconds is a very less time, so I will increase the time value. Let us kept instead of 10 seconds 30 seconds, 300 into 100, so that 30,000 milliseconds. 30,000 milliseconds is the 30 seconds. Okay, so now I kept that time as the 30 seconds. Okay, now for filling the bottle 30 seconds time is there. After 30 seconds the motor has to automatically off, right? So that means after 30 seconds time is elapsed, this T50 will be energized. So that T250 here you have to kept with normally closed contact, T250. Okay, whenever this is energized, as this is the normally closed one, it will open, so that Y0 will become off. Okay, see here I am pressing the on button and I will release it as it is a push button. Even though if you release it, Y0 will be in on mode only, right? So Y0 is on, that means motor is on and the water starts filling the bottle. So continuously up to 30 seconds. That means this count value, whenever it reaches to 300, it will become 30 seconds. After 30 seconds, the motor will become off. After reaching 300, the motor is off. That means water is filled completely. So water bottle is completely filled. Okay. So now Y0 is off. So this Y0 is also off. So even though if this Y0 is off, you see here this timer value is at 300 only. So what it means? It will not reset to 0 even though this Y0 is off. Okay. So in such a case here, what you have to do is you have to manually reset it. You have to keep one reset button, right, which is X1. Whenever you press X1, you have to reset the T250. Reset RST T250. Okay, when you press the X1 button, this timer T250 will be reset to 0. Right, on, release. So now your timer is start counting here. Okay, suppose in the middle, due to power cut, let us assume that this coil is off. Okay, due to suddenly power cut, your motor will off. Okay, suppose while filling the water bottle, power supply is suddenly gone, right? Then your PLC will be off, so the motor is also off. Okay, so motor is off in the sense Y0 will become off. Now after some period of time, that the power supply will come again, so then the motor will become on. So then it will start filling the water. So but the timer should not start from 0, but it will start from the previous value where it has stopped. Okay, so you see here, so whenever Y0 is off, the timer value is K162. So at K162 the power supply is off. Okay, right, whenever power supply is came, the motor will become on, and it will start counting from here itself, not from 0. So it will set up whenever it is on, it will start from 162. Okay, this is the feature of the accumulative timer. Okay, whenever it reaches to the, this will become off now, right? And it will even though if it is y0 is on, sorry, y0 is off, the value K300 will be there itself. Okay, the timer value will not automatically come to 0. So you have to reset it. So that reset will be done with an external switch X1. Whenever you press it, it will become reset. Whenever you release it, nothing will happen. So this is about the accumulative timer. Okay, I think you are understood. So if there are any doubts, you just post a comment in the comment box. I will reply to everyone. Thank you.